Okay, let's take a look at the question. Consider the titration of 25 milliliter and 0.19 molar of a weak base B in aqueous solution with 0.19 molar hydrochloric acid, strong acid. The Kb is 1.7 times 10 to negative 9. And we need to calculate the pH before addition of the titrant, any of the titrant. So, which means, even though this is titration reaction, but what is asked here, really, that's before the titration started. So first, before the titration started, we have to concentrate on the analyte. That's a weak base, a mono, because it's just B right here. So let's write the hydrolysis reaction, because before you add any strong acid, the titrant, this weak base will just naturally undergoes Kb reaction. So we have to use that reaction to find out the hydroxide concentration, then find out the pH from that. Okay, so this is a Kb reaction, and the Kb expression, the products on top and reactant on bottom. Water is pure liquid. We don't involve that in the equilibrium constant expression. Let's say before the hydrolysis. Before means before the hydrolysis. So then the weak acid, the relative quantity is 0.19. So it's molarity, but again, we use the relative ratio, we use the relative quantity to simplify the calculation. So, okay, 0.19, and then of course none of those two products were formed, so that's basically 0. But after you add the water right there, so then you would have X molar of the conjugate acid and the hydroxide. That's 1-to-1 ratio. So X molar of BH plus and OH minus. So, and then this weak base is quantity has to be decreased by X. All right. So, and now we'll just rewrite the Kb. The Kb is given already in the question. I will just write that down. BH plus is X. OH minus is X. So therefore that's X times X. So that's just X squared. And the concentration of B is just 0.19 minus X. Since the Kb values are so small, we can carry out the approximation. So we just drop this X, the X squared over 0.19. From there, X can be calculated using the square root of the product of the two. Okay? And then this value, make sure you understand, that's not H plus concentration, it's OH minus hydroxide concentration. So we can take the negative log of this value, then that should be POH. POH is 4.75. Then pH can be calculated using 14 minus POH, then that should be 9.25. And obviously, oh, how convenient. Okay. Don't do this to me. Yeah, obviously, the answer should be A, 9.25. Okay, that's the pH before adding any titrant. That's for this question.